Hello and welcome to this lab. So far in writing lab reports, you have been filling in the worksheets I have been providing. From this lab on, it is going to change. You will be writing your own report. Alright, there is no more filling in. And therefore, I'm going to give you the format of the report that you must be writing. Your report must start with the statement of the objective. That is the first. What does objective mean? What is the purpose of the experiment? For example, today's experiment, the purpose is to measure a value of g, the acceleration due to gravity. So that is what will go under objective. The second must be, well, if you look at the lab that I have provided, I have actually given you these details. The objective, the equipment used. Give a simple description of the equipment. That is the second item. And the third item I would like you to go through will be a very simple background of the theory. Now, I normally give a simple description of the theory. Alright, you can get that small description from my own description. But please don't copy and paste. Write it in your own words. I want to see your language there and not my language. So that will be number 3 is the theory. And what comes afterwards? A very important part. Number 4 is the method of the experiment. What did you do in the experiment? How did you set up the experiment? Now, if you read the method that I have described, these are instructions for you to carry out. Now, if you write it like this, you will be giving me instructions to do the experiment. And that is not what I expect you to do. Now, what I want you to do is to give me a description of what you did. For example, it reads like this here. Set up the system as shown with M1 equal to M2 equal to 100 gram. That is a set of instructions. When you write it, it must read as a reported speech. The equipment like this was set up. This mass was hung from a pulley. The mass was allowed to fall. Then I measured the time taken for the mass to fall through a certain distance. You see that? You must write it in first person, as though you are reporting what you did. And that is what should be in the method. Give a short but comprehensive description of what you did. It is very important because I will also be judging your writing skills in there. How good are you in communicating? You see, the ability of a college graduate to communicate effectively is very important. And I will be looking at some of those communication abilities in your ability to write a lab report. How well can you organize and write a good piece? Now, followed by the method will be the data. Well, the data normally involves a table of values. Now, the tables will be normally provided. So, you can actually, in many cases, copy and paste these tables and enter your values. So, number 5 is the data, and enter all the data there. And now, number 6 is interpretation of the data. How did you interpret the data? Interpretation of the data. Now, what would you expect to put in under this title? Interpretation of the data is generally the graph. Now, in most experiments, you will be required to draw a graph. Now, remember, I will ask you to write down an equation using the variables in your experiment, and I will ask you to write that equation in the form y equal to mx. Is that right? So, once you write the equation in the form y equal to mx, then your independent variable will be x and your dependent variable will be y, and you draw a graph of the dependent variable on the y-axis and the independent variable on the x-axis and measure its slope, and that is what is under interpretation. You will be drawing the graph on Excel or any other graphing utility that you can come across and copy it and paste it under interpretation. And after that, number 7 will be the results. What are the results of the experiment? Now, this is very commonly misunderstood by students. Now, for example, in the interpretation, you obtain the slope of the graph. Let me give you an example. In this particular experiment, your equation is going to read like this: m2 minus m1 times g equal to m1 plus m2 plus m sub f multiplied by a. And in the first part of the experiment, the acceleration will be a variable, and m2 minus m1 will also be a variable. All the other quantities are constants. So tell me, how will you write this equation in the form y equal to mx? Now, the independent variable is m2 minus m1. We will change m2 minus m1 and we will measure correspondingly. Now I'm going to make a small difference in here. I'm going to say m2 minus m1 is going to be a constant. I'm going to keep that a constant. And what is going to change is m1 plus m2 plus mf. Now, this quantity is going to change. Alright? Now, when this quantity changes, correspondingly the acceleration will change. Alright, so what is your independent variable? Your independent variable is m1 plus m2 plus mf. And when this quantity changes, the acceleration changes. Okay, now tell me, how will you write this equation in the form y equal to mx? Alright? Y stands for the dependent variable. Which of these two variables is the dependent variable here? It is a. So we solve that equation for a. We get a equal to, if you look at this, a equal to the quantity on this side divided by m1 plus m2 plus mf. Now look at the way I'm going to write it. A equal to m2 minus m1 times g multiplied by 1 over m1 plus m2 plus mf. Is that right? The quantity here divided by m1 plus m2 plus mf is written like this: m2 minus m1g times 1 over m1 plus m2 plus mf. Why did I write like that? You got the dependent variable and this is the independent variable. That means you need to draw a graph of A, the acceleration on the y-axis, and 1 over m1 plus m2 plus mf on the x-axis. And that graph will be a straight line, and the slope of that graph will be m2 minus m1 times g. Alright? And it is that slope that you have obtained in number 6. In the interpretation, you have now obtained the slope. And so, in the results, you must come in and say, I'm going to remove this now. Okay. You must start like this. You must say, slope of the graph, in this case, must be equal to m2 minus m1 times g. Suppose you got the slope in this case, you measured the slope and you got a value, so you then say measured slope equal to, let's say 0.09. And you must write the unit, whatever unit the slope had, you must write the unit. If that unit is missing, you will lose 0.1 of a point. Alright? 1/10 of a point for each unit missing. Alright? Measured slope is, suppose, I'm giving you a figure. So you must now take this value and set it equal to this. So 0.09 equal to m2 minus m1 times g. And in this experiment, this m2 minus m1 is going to be 10 gram. And 10 gram is 0.01 kilogram. So we will say 0.09 equal to 0.01 g. And that will give me g equal to 0.09 divided by 0.01, which is 9 meter per second square. So you must show me all these steps in the results. If you want, you can change the title, the subtitle 7 as calculations. You see, that will be a more appropriate title. Calculations and results. Alright, so you got the calculate the slope is used to obtain a measure of the quantity we are looking for. And now, once you calculated the value of g, you must obtain a percent error. The actual value of g, you know, is 9.8 meter per second squared. And now you can obtain a percent error using that. And all that must be in the calculations and result. You must understand the most important part of your report will be interpretation, calculation and results. And finally, I would like you to do one more step before you answer some of the questions I have. And that is, what are some of the precautions you did? You see, every experiment has limitations. You need to recognize some of the limitations. What are some sources of error in this experiment? What did you think were some of the sources of error, and how will you improve this experiment as a scientist? How will you improve the experiment? A very important step. In other words, give me some of your thoughts about the way the experiment was done and how will you improve it. And this is particularly important for you because I am an active partner for your lab. I'm actually setting up the lab. You are only sitting back and taking the measurements. Is that right? Okay, so I want you to look at the sources of error and how will you improve it. And finally, answer all the questions I have given you at the end of the lab. Answer all questions. And let me tell you one thing about answering questions. Now, when I give you a question, I just don't want the answer. Now, many students just give me the answer. When there is a problem to work out, I want to see all the steps of the problem. In other words, use the equation editor, the symbols and everything that the Microsoft Office provides, so that you write down all the steps neatly. And you must learn how to do it. It's an important skill. Alright? Give me all the steps of the problems and work out all the problems. And once the document is done, you must feel proud of producing a well done document. And then upload it and send it to me. And that is how you must prepare your lab report from now on. Alright? Any questions about this? Let me know. Alright, let's now talk about today's lab. In today's lab, you will need to take measurement of time. If you see on the background, I have set up the experiment. You need to measure the time taken for this mass to fall all the way to the ground. That means you need a stop clock. You can actually see how the setup is done. There are two masses connected by a string that goes over a pulley, and you will be allowing the system to move under a net force. That means you need a stop clock to measure the time. If you remember, in the CD I sent you with the introduction video, I also sent you an online clock, a digital clock. I want you to drag it from your CD. Now, when the CD, you put the CD in your CD-ROM and click on My Computer and click on the CD DVD drive, and then you will see the files. Drag the clock onto your desktop, just like I have it here. Now, I have the stop clock. You see where I'm pointing? Alright, click on it, and the stop clock should come like this. Now, if it says install or setup, go ahead and set up. Okay, now we are using the green, that is the stopwatch. Alright, click on it and your stop clock is now ready. When you want to start, click start. It counts in seconds. The only problem here is that you will be only able to count whole seconds. You don't get decimals. Well then, we need to live with it. Alright? And pause and clear. Okay, once you open it, you minimize it so that whenever you want it, you can access it. And now, you open the video for today's lab and start playing it. Now, I have a video open. Now, here is a video that is one of my lectures. Now, when the video is playing, you want to take a measurement, take the clock. Now, click on the clock that is on the status bar there and keep it at a convenient place. Now, you can actually make it small. Look at this. Click on the corner there and make it small so that it will sit at a corner. Now, sometimes when you bring up the clock, the video will disappear. The video will get minimized. Now, what you do is click on the video at the bottom so it plays, and keep the clock at the corner so that, look at this, so that it is available for you to use whenever you want. Okay, so make sure that you open the clock for this lab so that you can measure the time when you watch. As you keep watching, I will be asking you, alright, start the clock, and then, well, you will be able to do that on your own. Okay? Alright, now you are ready to start the experiment? Okay. Let's start by looking at the theory of the experiment. If you have two masses connected by a string that passes over a pulley, you have done that in the theory. We have covered this completely in the theory. Now, what is going to be the net force that sets the system in motion? The net force is provided by the difference between the two masses. In other words, F net will be equal to, hope you can see this, F net will be equal to M2 minus M1 multiplied by G. That will be the net force. Well, I'm going to call M1 the mass on my left and M2 the mass on my right. The difference between the two masses will provide the net force. And that net force will be equal to MA. Is that right? That F net, according to Newton's law, F net must be equal to MA, where M is the total mass that is in motion. What is the total mass in here that will be moving when I set the system in motion? Well, the total mass moving will be M1 plus M2. Okay, but there is a little more correction that you need to apply. Alright, let's go and look at the method of the experiment. I want you to read this experiment. Before you start the experiment, read the manual completely. Now, the method I have asked you, set up the system like this, with M1 equal to M2 equal to 100 gram. Now, each of the weight hanger is 50 gram, so I'm going to put in a 50 gram each. So I have 100 gram for my M1 and 100 gram for my M2. Add enough mass MF so that the system moves without acceleration. Now, you see the system is not now moving. If I give a gentle push to one of them, let's see if it's moving without, is it moving without acceleration? Well, it stopped. Why did it stop? Because although this pulley is supposed to be frictionless, it's a very good pulley. It offers a little bit of friction. So, what I'm going to do is, as I have said in the instructions, add a mass MF, which is called the friction compensation. So, I'm going to add a 1 gram to M2, a 1 gram to M2, and see what happens this time. Well, actually that 1 gram is a little too much. We probably would have been something less than 1 gram. Is that right? That 1 gram actually provides a net force. Alright. Now, since I don't have anything less than 1 gram here, we're going to say let our MF be equal to 1 gram. Alright? That's going to introduce a small error in the experiment because that 1 gram is a little too much for MF. Is that right? I think so. It's a little too much. Alright? Now, what do we do do next? Now the system has no net force. That means if I add an additional mass to one of these, that will be providing the net force. And what do? Now, what we're supposed to do is take the system in such a way that one mass is at the top, alright, M1 is at the bottom and M2 is at the top. Alright, I need to do a little bit of adjustment. I have adjusted this such that M1 is touching the floor and M2 is at a certain height from the floor. Now, the method requires that you measure that distance. Measure the distance y of M2 from the floor, and I have measured it. It is 142 centimeter. So the distance y equal to 142 centimeter, that is 1.42 meter. That is our distance y. Now take a note of that, and we need that distance. And what is the next one? Add an additional 10 gram. I need to find a 10 gram. I have a 10 gram here. Add that additional 10 gram to M2, and that means that 10 gram is going to be your M2 minus M1. So I'm going to add that, and then you see, once I added, there is a net force. This is going to fall if I let it go. Now what you need to now do is be ready. When I say ready, go, you start your clock. And when this goes and touches the floor, you stop the clock. In other words, you need to measure the time taken for this mass M2 to go all the way to the floor. Alright, are you ready? Alright, ready, ready, 1, 2, 3, go. Did you get the time taken by M2 to fall to the ground? Alright, let's do a couple more trials. Let's do a couple more trials. Alright. Remember, you need to start the clock when I let go and stop it when it touches the ground. Alright? Let's go. 1, 2, 3. There you go. Okay. I'm going to give you one more trial for you to measure that time. Alright, ready, go. I hope you got that time. So you got 3 times, find the average time, the time taken for the mass M2 to fall through what distance? Y equal to 1.42 meters. Now once you have the average time, calculate the acceleration of the system using the equation A equal to 2y divided by t squared. Do you know where that equation comes from? Well, that equation comes from here. When an object is dropped from a height y with an initial velocity 0, that y will be equal to 1/2 at squared. Therefore, solving for a gives you a equal to 2y divided by t squared. So calculate the acceleration using a equal to 2y over t squared. And now repeat the experiment for M1 equal to M2 equal to 150. So now Each of the weight hanger is 50 gram. So I'm going to put a 100 gram and a 100 gram. I have M1 equal to 150, M2 equal to 150, and now I need to find MF, the friction compensation, and I'm putting in additional 1 gram, and that 1 gram looks good there. So your MF is 1 gram for the second trial. Alright? So your M1 equal to M2 equal to 0.15 kilogram, and your MF is 1 gram for the second trial. What is the next thing to do? Create a net force. Now how are we going to create the net force? By putting a 10 gram on M2. Give a 10 gram on M2. In other words, you see, the net force in all our trials is going to be a constant given by or provided by this 10 gram, M2 minus M1. Alright, so we are now ready. This is now the second. We are repeating the experiment with M1 equal to M2 equal to 150 gram, and the first trial for the time measure. Are you ready? Alright? 1, 2, 3, go. Alright? Are you ready for the second trial there? Okay. Your clock ready? 1, 2, 3, go. Alright, you got 2 times, find the average. I'm not giving you a third trial this time. 2 times are enough. Alright, now we repeat the experiment by changing M1 and M2. What are the new values of M1 and M2? I need to make M1 equal to 200, M2 also equal to 200. I have 150 each there, so I'll put a 50 on M1, a 50 on M2. That means I have M1 equal to 200 or 0.2 kilogram. M2 also is 0.2 kilogram. And I need to measure the MF, the friction compensation. And I'm going to try that 1 gram again and see whether that will work. Well, it's moving uniformly, is that right? That works fine. So MF equal to 1 gram again. You see, normally, if this pulley is the bad pulley, the friction will keep on increasing. But I have got a very good ball bearing pulley for you. That means the friction is very small. Alright, so your MF this time is also only 1 gram. So once again, M1 equal to 200 gram, M2 equal to 200 gram, your MF is 1 gram. Alright, take M2 all the way up at a distance y from the ground, and what is our y value? Y value is 142 centimeters. Now create the net force. How do you create the net force? By putting a mass 10 gram on M2, so that M2 minus M1 is now 10 gram. And that remains a constant for all our trials. Okay, are you ready to measure the time? Alright, ready? 1, 2, 3. Okay. Are you ready for trial 2? Okay, ready? 1, 2, 3. Okay, you got 2 times for that. Find the average and calculate the acceleration. A equal to 2y divided by t squared. Next, we repeat the experiment with M1 equal to 250. M2 also is 250. So I'm going to remove a 50. I removed a 50 and I put a 100 in its place. Do I have another 100 in here? Well, no. So I'm going to put two 50s. So that gives 250 M1, and I need 250. Is that right? 250 for M2. I have M1 equal to 250 gram, M2 also equal to 250 gram. I need to find the frictional force, so I'm going to try 1 gram again and put 1 gram on M2 and give it a small push. Well, it's going, you can see that friction has not increased. It is still 1 gram good enough. Okay, so once again, my M1 is 0.25 kilogram, M2 is 0.25 kilogram, and my MF is 1 gram. And I'm now going to add a 10 gram to M2 to create the net force. Alright, the net force is always a constant. Are you ready? Alright, get ready to measure the time. 1, 2, 3. Alright, disregard that. There was a little violent reaction between the two. You can see my setup is very precarious one because the pulley is not very wide, so you've got to be very careful. Now let me just align the masses so that they will not interfere. Alright, so we'll do trial one more time. Ready? Let's see if it's going to work this time. 1, 2, 3. Okay. Let's now do the second trial. Okay. Ready? 1, 2, 3. Okay. I'm going to give you one more trial for that particular time if you missed any of those. Alright, 1, 2, 3. There we are. Now, if you find the online stop clock a little difficult to use, you can use your cell phone. Most cell phones have got the clock that can be used as a stop clock. That also is a little more accurate because you can measure decimal seconds. Okay? Well, whichever is convenient, try and measure the time as accurately as you can. In our next trial, we need to make M1 equal to 300 gram. M2 also is 300 gram. Is that right? Yes. So let's make 300 grams. So I'm going to remove these. I'm removing the 50s and also the 100s. I'm going to use these 200. Each of these is 200. So this 200 plus 50 is 250 plus I'm putting a 50 there. So I have now each mass M1 and M2 both equal to 300 gram, 0.3 kilogram, and let's try MF. I'm again going to try 1 gram, and you can see it works. Amazing, this pulley is very efficient. There you are. Okay, well, let's take M2 all the way up. M2 goes all the way up and creates the net force by adding the 10 grams. So here is the 10 gram added to M2. Ready for measuring the time? Alright, ready, 1, 2, 3. Okay, one more trial. Let's do one more trial. Okay, ready, 1, 2, 3. Well, we got 2 trials and that's enough for that. In the next trial, M1 is to be 350, M2 also is 350, so I add a 50 to M1, another 50 to M2, so that M1 and M2 both are 0.35 kilogram. And let's test MF, if it is going to be any different. Well, I'm going to try that 1 gram again. Well, I think that works this time also. It's moving almost uniformly, is that right? There seems to be no friction at all. So your MF this time also is 1 gram. So one more time, M1 equal to 350 gram, M2 equal to 350 gram, and your MF is 1 gram. Let's take M2 all the way up, and now set your clock and ready, let's go. Let 1, well, I have to create the net force. I put the 10 gram to create the net force. Alright, ready, 1, 2, 3. Okay, let's give it one more try. Okay, are you ready to go to the next trial? Here we are. Okay, let's go. 1, 2, 3. Okay, I think we have now done all the trials. I'm going to give you one more trial for that 350 gram. There, 1, 2, 3. There we go. Well, I think that finishes our first part of the experiment. Now, in this first part, what were the variables? We changed M1 and M2, is that right? M1 plus M2 we kept on changing, and that will therefore change the acceleration. And we kept the net force a constant. The net force was provided by this 10 gram, and that remained a constant. In the second part of the experiment, we are going to do the same thing, but in a different way. Alright, let's now go and do the second part. And if you look at page 2 at the top, the method of the second part, how does it say? Set up the system with M1 equal to 260 gram, and I have given you the breakdown. 260 gram is hanger plus 200 gram. Well, I don't know whether you can see this. A hanger plus 200 gram, and what else? Plus a 5. I have a 5, so I'm going to put a 5 there. Plus 2 2s. I have a 2 2s and a 1. There you are. And that makes this 260. So the hanger is 50 plus 200, 250, then a 5, 2 2s and a 1. So I have 260 gram on M1. And what is going to be on M2? On M2 also 260 gram, and we're going to have that as the hanger plus 200. The hanger plus 200 is 250. And I put another 10 gram. That is 260. So I got both M1 and M2 now at 260. Alright, what do we do now? Well, obtain MF. We need to obtain MF. Well, let's try that 1 gram there and see. There you are. Well, that MF is a constant. There you are. Okay. And we've got MF that is 1 gram. And you see, the important thing in here is the total mass M1 plus M2 is not going to change in here. And that is the significance of this part. M1 plus M2 will not change. I want you to watch this carefully. Well, first of all, we take M2 all the way to the top. And how are we going to create the net force if M1 plus M2 is going to remain a constant? Well, look at the 4th line in there. Transfer 1 gram from M1 to M2. Now, I want you to watch what I'm doing. I'm going to take 1 gram from M1 and transfer it to M2. Now tell me. Now, both M1 and M2 were equal. And now, 1 gram is taken from M1 and put on M2. What is now the difference between the two masses? The difference between the two masses is now 2 grams because M1 lost 1, M2 gained 1. Is that right? If both of us have $10 in our pockets, and if I come and take $1 from your pocket and put it in my pocket, what is now the difference between the money? It is $2 because you lost 1, I gained 1. In the same way, the difference between M1 and M2 now is 2 grams, and the net force is going to come from those 2 grams. So, the net force is now going to be provided by that 2 gram in this case. Alright. Now, I have that 1 gram that is transferred. Are you ready to measure the time? Let's do our first trial. Let's go. 1, 2, 3. There you are. It goes pretty slow because the net force is very small. Alright, let's measure that one more time. Alright, ready to go? Okay. 1, 2, 3. Okay, you got 2 time values for that. Now, in the next trial, what do? Well, in the first trial, we removed 1 gram from M1 and put it on M2 so that the difference between the two masses is 2 grams. Now, I'm going to return that 1 gram and I'm going to take 2 grams from M1 and put it on M2. So, I now removed 2 grams from M1 and put it on M2. Tell me, what is the difference between the two masses now? Well, the difference is now 4 grams. So what are we changing now? We are changing the net force. Remember, in this part of the experiment, we are changing the net force. We are keeping the total mass that is moving a constant. Alright, now, I removed 2 grams from M1 and put it on M2, so that the net force is now provided by the 4 grams. Alright, let's measure the time. Ready? 1, 2, 3. Okay, let's do that one more trial. Alright, there has been a little clash, but that's okay. Okay, let's measure the time one more time. Ready? 1, 2, 3. Okay, we have the time for that. And now how do we repeat this? First we took 1 gram from M1 and put it on M2 so that the net force is created by the 2 gram difference. Then we took 2 grams from M1 and put it on M2 so that the net force is provided by the 4 gram difference. Now, take 3 grams. That means I need only remove that 1 gram from M1 and put it on M2, so that I have now removed altogether 3 grams from M1 and put it on M2. Right? So what is the difference between the two masses now? The difference is 6 grams. Okay? So the net force is now going to be provided by the weight of that 6 grams. Alright, ready? 1, 2, 3. Okay, let's do that one more time. Let's try one more trial for that time. Let me pick the fallen pieces. Okay, let's give another try. Ready? 1, 2, 3. Okay. Alright, now tell me, how am I going to repeat this now? Now, so far I have removed 3 grams from M1 and transferred it onto M2. Now I need 4 grams. So what I'm going to do is, I have a 2 gram, I'm going to remove a 2 gram from M1 and put it on M2 and move the 1 gram back. That means altogether I have now removed 4 grams from M1 and put it on M2. Tell me, what is the difference between the masses now? I have now removed 4 grams from M1 and put it on M2. What is the difference between the two masses now? M2 minus M1 now is 8 grams, and it is the weight of that 8 grams that is going to produce the acceleration. Okay? Alright, ready to go? Alright, 1, 2, 3. Okay, let's do it one more time. Okay, ready? 1, 2, 3. Okay, you have 2 trials on that. Now how do we repeat this again? Remove 5 grams from M1 and put it on M2. Is that right? Okay, let's do that. So we need to remove 5 grams from M1 and put it on M2. So M1 is now 255 gram and M2 is 265 gram. So the difference between the two is now 10 grams. Okay, now let's go. The net force is now provided by 10 grams. Alright, you ready for the first trial? Okay, ready, 1, 2, 3. There you go. Alright, let's do another trial. Ready? 1, 2, 3. Okay. Now, is there any way we can repeat this one more time with this arrangement? Anybody tell me, is there any way I can repeat this one more time using this arrangement? Yes, I can. I can remove all the 10 from M1 and put it on M2. So that means the remaining 5, I took it and put it on M2. That means my M1 now is 250 grams. You see, my table that I've given you does not include that. I want you to include that also. Alright? So M1 is now 250 grams. M2 is now 200. Tell me, what's that M2 equal to? 270 grams. The net force is now provided by the difference between the two masses, which is 20 grams. Alright, let's go. Ready? 1, 2, 3. Okay. Let's do it one more time. The difference between the masses is now 20 grams. Let's do that one more time. Okay, ready? 1, 2, 3. Okay. Let's now spend some time interpreting the data we have taken and how do we get our results. The objective of this experiment is to find the value of acceleration due to gravity, g. Alright, in the first part of the experiment, do you remember? What were the variables? What did we change and what was remaining a constant? In the first part of the experiment, we kept the net force, M2 minus M1. It is the M2 minus M1 that provides the net force for the system to move. We kept that a constant. M2 minus M1 was 10 grams right through the experiment. What did we change? We changed M1 plus M2 plus MF. But MF right through was 1 gram. So the total mass moving was this, under the action of this net force. Alright? How do we write this in the form y equal to mx? I just showed you in the beginning of today's lesson. So if you want to write it in the form y equal to mx, you need to figure out what is your independent variable. Your independent variable, you allowed to vary what? This quantity, m1 plus m2 plus mf. And when that was changed, then the acceleration changed. So acceleration is the dependent variable. Solve for the acceleration. We get a equal to m2 minus m1 multiplied by g divided by m1 plus m2 plus mf. So I'm going to multiply that by 1 over m1 plus m2 plus mf. So you will now draw a graph of the calculated acceleration on the y-axis and the reciprocal of m1 plus m2 plus mf. And that's the reason why in the table here, if you look, I have given you a column for calculating that quantity, 1 over m1 plus m2 plus mf. This is for the purpose of drawing the graph. Okay, and once the graph is drawn, measure its slope, and the slope will be equal to this quantity. So set it equal to this quantity, where you know m2 minus m1 is 10 gram, 0.01 kilogram, and then calculate a value for G and obtain a percent error of your calculated value. Alright, how about the second part? Now, the equation for the second part is the same. The net force is provided by m2 minus m1, and that net force produced an acceleration A on m1 plus m2 plus mf. But what's the difference? Well, we did not change m1 plus m2 plus mf, did we? Well, we simply moved a certain mass from m1 and put it on m2. So, although m1 and m2 changed, m1 plus m2 never changed. That means m1 plus m2 plus mf in the second part is a constant. But what was our variable? We changed this, m2 minus m1. We moved 1 gram from m1 to m2 so that m2 minus m1 is 2 grams. Then we moved 2 grams from m1 to m2 so that m2 minus m1 is 4 grams, and so on. So it is this quantity that changed. Alright, tell me which is the independent variable and which is the dependent variable. We changed m2 minus m1, and as a result the acceleration changed. So we are now going to write this equation as A equal to m2 minus m1 times, that's a variable, look at the way I'm going to write it, times G over m1 plus m2 plus mf. Is that right? When you solve for A, you get A equal to m2 minus m1 times G divided by m1 plus m2 plus mf. Why did I write like that? Well, I'm going to write it a little more differently. I'm going to say is equal to G over m1 plus m2 plus mf times m2 minus m1. Now, this is of the form y equal to mx. So your graph will be acceleration on the y-axis and m2 minus m1. We should understand that this is a small quantity. 2 grams is 0.002 kilogram. So your values of m2 minus m1 will be these values: 0.002, 0.004, 0.006, 0.008, 0.01, and finally I think 0.02. These are your m2 minus m1 values, and the acceleration values you calculated. So in your graph you must use those. These are your x values, and the acceleration is your y values, and then measure the slope. Slope will be equal to this quantity. And you know this, don't you? m1 plus m2 plus mf. m1 is 260, m2 is 260 gram, mf was 1 gram. 260 plus 260 is 520, so that will be a total of 521 gram which is 0.521 kilogram. That is m1 plus m2 plus mf. So your slope, you must bring your slope like this. Let me take this off. You got to come and say, therefore, your slope equal to g divided by 0.521. Now the graph gave you this value, and therefore you can calculate your g. Okay, is there anything else that you want my help with this? So after drawing the graph, remember, draw the graph on Excel and copy and paste it at the appropriate place. Make your lab report really neat and tidy and well organized. Okay, and answer the questions. As I told you, the questions must be answered with sufficient details, giving all the steps. And if there is a diagram necessary, draw a diagram. I showed you in the introduction movie how to use the draw menu to draw diagrams. It is an important and good skill to know these things. Alright, I think I took a considerable amount of time giving you instructions on this lab. Alright, now spend some time on your own and prepare your report. I will see you for the next lab later on.